This is a part two of writing conventions for writing mathematics. This is not so much strategies of how to write proofs, but kind of nitpicky details of what to do and what not to do when you're writing mathematical proofs. So let's jump right to it. Okay, this is a continuation from video last Tuesday. Okay, so it's a quick advice. When you're writing a longer proof, you should include motivation before you write down your proof, or maybe at a halfway point. You should let the reader know what the structure of the proof is or where it's going to go. So it is very frustrating to read very complicated argument where you don't know where the argument is going. So this is a good courtesy if it's a longer proof. Another thing that you might have known, or maybe you might not have heard before, when you're doing mathematical writing, you don't use first person singular. So you try to avoid words like I or me when writing in mathematics, even if you're the only author for the paper. So what to do is use the we whenever you could interpret it as the writer and the reader. And the explanation of why I've heard this is done is because you're never doing mathematics by yourself. You're always building on someone else who's done mathematics before you, and you're also kind of doing it with the reader of the paper as well. So you use we even if you're the only person writing that paper. That might sound weird, but it's all the math papers work that way. So you use phrases like, we will prove this theorem by induction on n. You don't have to know what induction is, but you use the word we, even if you're the singular student who's writing that proof. You could also use it in this example. Because the triangle ABC is equilateral, we see that AB is equal to BC is equal to CA. So you're including the reader as you write that. Okay, so sometimes there are exceptions to this. If you want to talk about you as a singular person, then you could use I, and you don't want to include the reader or any mathematicians who came before you. So an example of something that I've read is something like the phrase, I learned this technique from Chris Birdie. So with this sentence, you're giving credit of where you learned the technique to prove something. So then you're not talking about you and the reader, you're talking about yourself. So that's a minor example of an exception. But most of the time you use the word we whenever you refer to yourself. Okay, when you're writing the proofs, you should avoid abbreviations as much as possible. Like there are a lot of common abbreviations like ST for such that, or WRT for with respect to, or what we learned last time, assume without loss of generality, log, right? These are good things to have in your notes when you're writing to yourself. But if you're writing to an audience, like a proof, which is written for somebody else, for them to consume, then you should drop those abbreviation when you're writing the final draft of the proof. There are some exceptions. You could use subject-specific acronyms that's used all the time. For example, so if you've taken a differential equations course, you might have seen the abbreviations ODEs many times. It's short for ordinary differential equations. If it's specific to a subject and you're writing for that subject, it makes sense to use those acronyms. But remember, in this class, you're writing towards your colleagues, which is should be thought of as the beginner of young mathematician who's learning. So if you started using these acronyms, it's kind of impolite to assume that they know what you mean when you start using technical jargon. And even if you do use these type of acronyms, the first time you use it, you should teach the reader what that stands for. Okay. Next advice, you should proofread, especially a difficult proof that might have taken you until 2 a.m. to write. When you write a proof, like you're going back and forth, you erase things and rewrite things. When you think you've got it, you might have the thread of the right argument, but you should, as much as possible, like give it some break, then come back to the proof and read it from beginning to end without any breaks, and see if it still makes sense. You can catch so many silly mistakes that way. So I highly recommend to proofread all of the proofs you write. Okay. So one more nitpicky details about what to do when you're writing mathematical formulas, or I should say really typing mathematical formulas. So one thing that you might have known, but maybe it's possible that you haven't realized it. When you do mathematical symbols, like maybe X and Y for variables, or F for a name of a function, all of those are italicized. So if you're typing it up, you should highlight it and do Control I, or click on the italicized icon to make it italicized. This goes for like name of sets. Like if you want to write a set A, that should be italicized, and so on. So yeah, so variables, constants, functions, sets, everything should be italicized. There are two main ways to write down equations when type out equations on paper. One is called inline formula. That's when you write down equations or inequalities within the line that you're typing out. So if x is a real number, then x squared is greater than or equal to 0. So this all fits in one line, and you can kind of type out as you write your sentence. You could do this as long as the equations or formula you're writing down is not too complicated. It fits in that line. If you're writing a more complicated formula, you can do what's called the displayed formula. And then when you write down an equation, it'll hold its own line. It's always centered, and it kind of takes up as much vertical space as needed to write the equations in a beautiful way. So these are called displayed formula. And you don't always have to do this, but when you write a displayed formula, probably you're doing that because it's big. And when you want to refer back to it, you can kind of number the equation on the either the right margin or sometimes the left margin, so you can refer back to it. And then once you name it, you can come back to it and say, oh, remember equation one, and so on. So that's called displayed formula. And either way, when you're doing the inline or displayed formula, these are parts of English sentences. So you can put period if it's appropriate, right? So after the equation, if that's where you want the sentence to end, you can put period there. Although I should say this is how I was personally taught, but I have seen textbooks that break this rule, so maybe I shouldn't be so harsh. So I guess there's conflicting philosophies on how to write this. So maybe I'll put a question mark here. Okay. And it is a bad form to start a sentence with a mathematical symbol. So you shouldn't start with X is an odd number. That shouldn't be a sentence you write down. You could say that thing like you could rewrite the structure of the sentence. So maybe you'll say integer X is an odd number, or some other way so that the variable name or a function name is not the first thing that appears in a sentence. Another thing that might be not obvious is that you shouldn't be using, so sometimes logical symbols are appropriate, but you shouldn't mix in logical symbols to connect English words. Example might be something like this. So this is a bad way to use logical and. So remember, logical and, it looks like that wedge symbol. So if you want to write down x squared is positive and rational, you probably should use the English word and the to connect the two English words positive and rational. Okay, so this is a bad example of using logical symbols to connect. But if you're connecting formulas or expressions, sometimes logical symbol is perfectly appropriate. So this is a good example of a good use. So we will prove that A if and only if B by first showing A implies B and then showing B implies A. So A and B are equations or expressions. So if you have symbols before and after these logical symbols, it's perfectly fine to write or type that way. Okay. And I think this is the last point. So sometimes you get what's called chain equalities or chain inequalities. So you write down multiple statements connected by equal sign or inequalities. So if you write A equals B is less than or equal to C, which equals D, when you write that, that's a shorthand for saying each of these pair things are comparable. So A is equal to B, and B is less than or equal to C, and C is equal to D. So this four things chained together is really three separate statements that's changed that way. And then you write that because you want to compare the very first thing on the chain to the very last thing on the chain. So when you write this, what you really communicate to the reader is that because of these chain equalities and inequalities, A is less than or equal to D. So that's how you use these chain equalities. So there's a couple things that you're not allowed to do. You should not mix in different directions of inequalities. So you can't write down things like A less than or equal to B, which is greater than C. Because when you write it this way, I mean, these two statements might be true, but you can't really compare A and C because, well, I know that B is bigger than both A and C, but it doesn't say anything about how A and C is compared. So don't mix, you can mix equality and inequality, but only one direction of inequality. So this is not allowed. Another thing you can't chain is inequalities. So when you write down A is not equal to B, which is not equal to C, this is not allowed because this is not clear what the relationship of the beginning expression and the last expression. Because you could have A not equal to B and B not equal to C, but A might be still equal to C because it's not a transitive relationship. So it's unclear when you write this. Do you mean that A is not equal to B or B is not equal to C? Or do you mean all of these three things are not equal to each other? Because it's unclear, it is not allowed. Okay, so these are how you write down chain equalities or inequalities in an inline form. You could also do it in the displayed format as well. So you might get something like this. So you don't have to know what these symbols are saying, but if you want to show that this is equal to that, and this is greater than that, and this is equal to that, this is how you might write it in a displayed format. So what's important is that equalities and inequalities are kind of stacked at the same like a column. So that's how you do chain inequalities when the expression is very big. All right, so that's all the conventions I want to cover for today. So I will see you next week. So I should say that before I let you go, that next week, instead of having practice quiz 2, what I want to do is do a proof workshop instead. So I will give you more directions on what to do on Wednesday, but it's going to involve peer reviewing other people's proofs. So it's going to be a two-step process. On Wednesday, I'll give you a proof you can brainstorm and write down. And that thing is due on Wednesday or at midnight of Wednesday at the latest. And then on Thursday, like you'll be reading other people's proofs and you post the feedback by Friday. And then everybody should have some feedback if you posted it by Wednesday night. And then the revision of your proof is going to be due Tuesday on the following day. So this is going to take some coordinated, synchronized submissions. So please, on Tuesday when the proof workshop is posted, please do it before Thursday. I'll talk more about it on next week's video. All right, I'll see you guys next week.